Hey everyone, we're going to take a look at number 12 in section 3.3. We're going to find the derivative f prime of x if f of x is equal to this expression. Okay, now this is a quotient, and this is in the section that we're dealing with the product and quotient rule. However, it's much easier to simplify this first. In other words, because I'm dividing by this single monomial, if you will, term, just an x, I can divide both the terms in the numerator, right? Distribute, in other words, dividing by x is the same as multiplying by 1 over x. So I just distribute the 1 over x through, right? And then each of these can be further simplified because it's just x to the first power down here. What do we do here? X to the 5/2 divided by x to the first. We subtract the exponents. 5/2 minus 1 is 3/2. So I get 2x to the 3/2. 7 divided by x is just 7x to the negative 1 power. Now I can take the derivative without any quotient rule, right? Just power rule. What's the derivative of x to the 3/2? 3/2 x to the 1/2. Subtract 1, right, from 3/2. Minus 7 times what? Derivative of x to the negative 1, bring the negative 1 down. X to the subtract 1 from negative 1 is negative 2. Okay, and so just cleaning it up, 2 times 3/2 is 3, x to the 1/2, negative times negative, positive 7x to the negative 2. Rewrite this in fraction form. X to the negative 2 is 1 over x squared, 1 divided by x squared, and here's my derivative. So not too bad, right? What's it look like if I use the quotient rule? I say it's much easier. Maybe I should just say easier, because it's really not that terrible actually when you use the quotient rule. So remember, the quotient rule is if I have u divided by v, derivative of u, the top function, times the bottom, minus the top times the derivative of the bottom function, all over the bottom function squared. So the top function u is 2x to the 5/2 minus 7. What's the derivative of that? Well, if I bring the 5/2 down, 5/2 times 2 is 5, x to the subtract 1, 3/2 power. So there's my derivative. Notice the derivative of 7, of course, is 0. So it's just the derivative of that first one that shows up, times the bottom function, which is x. All right, and then minus the top function times the derivative of the bottom function. Remember, the bottom function was x, and the derivative of x is just 1, divided by the bottom function squared, x squared. Well, now I just clean this up. Here I got x to the 3/2 times x. I add the exponents. I get x to the 5/2. And then here I distribute the negative 2x to the 5/2 minus times minus positive 7. And then I can combine these are like terms up here. I get 3x to the 5/2. So here's my derivative. Notice again, I have to split this up like I did before, similar to what I did before. Divide both this and this by x squared, and then simplify. This simplifies down to what? 5/2 minus 2 is just 1/2, 3x to the 1/2. And notice here, it's the same thing I have at this point, right? And so it's actually either way is not too bad in this case. But a lot of times, if we simplify first, it becomes easier a lot of times, and maybe even much easier to do. But you can't always do that, so you still have to be able to do the quotient rule. So I think either method, either way of doing it is good.